This is what we're going to finish making today. I started this process in my last video where I got most of this underside geometry made. Now we're going to finish off the top here. We're going to do that on my custom tombstone. We're going to start by clearing away all of the excess material with an adaptive clearing and a Lakeshore Carbide 3-flue end mill. 3/16 3-flute. Then we're going to move down to a 1/8 inch 3-flute. This one's from OSG. And that's going to peck away all of the material the 3/16 is going to get into. We're going to do finishing passes on the left and the right sides here with that same OSG 3-flute. And then we're going to finish the spots here for the watch band again with the same tool. Then we're going to go to a drilling operation with a drill that's about 50 thou. It's actually 1.25 millimeters. And it's going to drill the pockets for the spring bar. And it's going to give us a pilot hole on the pockets for the button, or for the buttons. And then to the other side, again, spring bar holes, button holes. And then we're going to go in with a 1/16 end mill and clean up all of the buttonholes. It's stepped here, so it's broken up in two different operations. It'll do the big step first and then the little step all the way around. Then we are going to do a finishing pass on these fillets with a 2-flute 1/8 inch ball mill. This one's from Harvey Tool. Actually, we're going to do a semi-finishing and then a full finishing pass here. I found that got a more consistent finish. And that should get all of the curves all the way around. Then we are going to finish the face here. Going back to the OSG 3-flute 1/8 inch end mill. And then we are going to do a finishing pass on the inside wall here, all the way around, and then it's going to eat its way through a little hat of material that we're going to have left and cut the watch out from the screw that is holding the whole workpiece in place, and also going to finish that wall. This is what I'm most worried about. I'm probably going to break that end mill. I've just accepted that, but I haven't found a better way of doing that yet. This is what the workpiece from last time looks like. I've actually had to make this again. The first time I ran it, the one you saw in the video last time, I didn't have the 1/16 inch tool to do a finishing pass on the inside here. So this was oversized and wouldn't have fit on my custom fixture on the pocket NC. So the other night, I just ran another one. Now that I have the code proved out, it's actually pretty hands-off and wasn't that difficult to run. And the finishes on this one are better because I got some better tools in from Lakeshore Carbide, and I was able to tweak my code and my speeds and feeds from what I learned last time. I've had a little bit of time to do some experimenting and measuring, and within what I have the ability to measure right now with my calipers, this inside pocket seems to be in spec. The problem is, even with it in spec, is it does not fit on my custom fixture here. And that's okay. I intentionally left this a little bit oversized. But we need to fix that before we get started. So the first thing we need to do is run a couple more light passes on the fixture until it fits this. My fixture here is measuring 6 thou oversized. My actual part here is measuring dead on. So I need to take off at least 6 thou on my fixture to get it to fit here. First thing I'm going to do is put in my 3/16 end mill, and I'm going to run a spring pass of what exactly ran last time on here to see if that changes anything. All right, everything's ready. This should be a very conservative tool path that takes off almost nothing, or maybe doesn't even touch the part. Okay, that definitely didn't touch the part. I'm going to take off some stock to leave in cam and rerun it. So I found a mistake. I meant to give it 3 thou stock to leave. I gave it 30 thou stock to leave. So that was never going to touch the part. I'm going to put it back to 3 thou, not 30 thou, and try again. Okay, that was a good, just very light spring pass. It should still not fit. It's still not fit. So let's walk it in by, I think we can do a thou this time. Still not quite there. I'm just going to keep repeating this until I get a good fit. So that took a lot of passes, but I'm very happy with the fit. It is basically perfect. It goes on fairly smoothly. It might be a little bit difficult to get off, but I think we can manage that. There is zero wiggle whatsoever. It is beautiful. All right, time to move on to the actual part. We're going to start with the same tool that I've been using to clear away most of the hat left on this part from the first op and start to rough out, actually do most of the roughing on the top. This is really starting to look like a watch, and it's awesome. That's the most of the material removed. Next couple ops are basically just removing little bits of material, just chipping away at any extra stock that's left that we couldn't get to with the 3/16 end mill, and we're going to just start stepping down sizes. I'm a little bit worried about, it's kind of hard to see, but there's some nubs here, and I'm kind of afraid that the ball nose end mills will not crash into those, but suddenly hit more load than they're expecting. That could cause finish issues. But there's a whole bunch of tools to run first, and maybe one of those will chip that away. So this is the next tool. This is a 1/8 inch OSG 3-flute high helix end mill. So far, I've been pretty happy with this one. I think I actually like the Lakeshore Carbide version of it better, but I'll use this one until I murder it. So that last toolpath did go pretty well with the 3/16 end mill. There's two things I didn't tell you. I just slowed down my feeds and speeds a little bit. The other thing that I did is I got a little piece of flappy aluminum hanging off of the part as it was cutting, and I just cut that off with a pair of side cuts because I didn't want it flapping against my end mill and breaking something. Or the 1/8 inch tool just finished, and I'm going to be honest, I was out of the room the whole time that was running. I thought I had longer. The roughing part of it seems to have gone fine, but the finish passes, particularly on the top and the bottom of the watches where the watch band goes, the finish is not good. The sides seem to be fine. So I'm just going to rerun those 2D contours that are the finishing passes, probably just as a spring pass. I'm not going to take off any more material, and that'll hopefully clean up the sides a little bit. I'll have to do some testing on this and improve my speeds and feeds, because obviously what I had here didn't work. I'm probably running too fast, because that's what I always do. And this time I'll get that on video. That was definitely better. Finishes are improved. I think I'm just going to run it one more time because I think it will still help, obviously. Up next, we're going to do a whole lot of drilling with a little tiny drill bit. This is that 1¼ millimeter drill bit that does the roughing for the buttonholes and drills the holes to size for the spring bars. Next up is a 1/16 inch Lakeshore Carbide 2 flute. This will be boring out the buttonholes. I almost just crashed everything. I didn't load the new program, so it was going to try to drill with the tool that I had just put in there. Let's try this again with no near disasters. Hopefully. Fingers crossed. I'm going to go get the button to do a test fit with it so I can walk in the diameters. This is my button from the existing Casio watch. I'm not going to be making these buttons myself right now. They do a very good job with these little buttons, and I do not have the skill to replicate them yet. Give me a little while. I could probably eventually get them done on the lathe. So far in all of my prototypes, I have not had a button that has actually functioned. I'm hoping this one will be the first functioning prototype with a button. So first thing I'm going to do is test the fat part of the button in that bigger hole. Okay, it seems like I've actually oversized it for the top of the button, the fat part of the button, which obviously I can't go back and fix now without doing a whole new watch. And now I'm going to try the other end of the button. I can't tell right now what the fit feels like for sure. I think it might actually be too loose as well. It's kind of springing back out, which makes me think it's because of the O-ring on here. I'm just going to finish this part and see how it fits with the actual movement in there. Because right now I think it's hitting the fixture where it should be able to go farther in, or it will be able to go farther in once the fixture's not in the way. So basically my result is inconclusive. This didn't tell me anything. Well, it told me it was too big, not too small. Up next, we have the 1/8 inch 2 flute ball mill, and this is going to do a whole bunch of finishing. I just had to stop that. That did not sound right. I think it was taking a deeper depth of cut than I intended for some reason. So I'm going to go back to cam and break the semi-finishing up into 2 steps. Which is going to take a while, but that's just the way it goes. Alright, so now it's going to take a total of 3 step downs. It's going to do 2 5/10 step downs, and then I think it's 2/10 step down for the final finishing pass. The finishing pass is done. Finish is still not perfect. I need to figure something better out than what I've been doing, because on both sides the finish is underwhelming. So I'm going to play with some 5-axis tilts to get a better surface speed on those ball end mills and not be cutting on the tip. I think that will help, but I just need time to do that. And I think this is good enough in the meantime. Now that the ball mill is done, I'm going to go back to my 1/8 inch end mill, and we're going to clean up the face that's underneath the crystal, or whatever you want to call the plastic bit on top of the LCD screen. So that wasn't right. It plunged through the little hat that's left. I think everything's still fine. I think I need to add a toolpath to clear away more of that hat before finishing. I think that's my problem. Tool's fine. All right, so let's do a 3D adaptive. We're going to limit it by that and that. We want it to be inside that boundary. Yeah. Let's give it a little safety margin from our screw too. 20 thou. Oops. Select our right tool here, which is not that one. Nope, that's Harvey. Here, let's sort. There we go, OSG. Select that one. And actually, I changed my mind on my, there we go. So now I'm gonna have it constrained by that and by that. And then we'll give it a slightly larger offset, 0.05. Maximum roughing step down. I want to be really gentle on this one. Maybe 20 thou step down. Again, trying to be gentle here. Stock to leave, smoothing, feed optimization, that's fine. Let's see what that looks like. Now, one more thing before it generates. We have to make sure rest machining is on. Rest machining from previous operations. Okay, and let's move this to the right spot, which is right there. We'll unprotect that, protect, and regenerate these two. So you can see that spiral in right there on the horizontal. That's where it hit material last time that I wasn't expecting to be there, wasn't thinking about. And it would have kept hitting that tall piece of material as it went along this section. All right, our adaptive's thinking. Okay, it's staying plenty far away from the screw there, and it should take out most of that material. So once this is done, I'll go ahead and run it. and then we'll run the horizontal. I was trying to keep as much of this hat here around as much as possible, because that is where all of our clamping force is coming from this screw. And so it'll be more rigid the more material we have here. Because this wall is only like 10 thou thick or something like that. So not a lot of rigidity there. But I think this is where we need to cut all the way through. That's a lot of toolpath. I just rehomed everything just in case we lost any steps in that rough toolpath. Now I'm going to retouch off the tool, again, just to make sure that if the tool slipped or whatever, that's not going to cause problems now. I have no idea why, but my end mill decided it wanted to eat the screw. Definitely destroyed that end mill. Let's see if we can find Y and cam. Oh, yep, right there. You see that? Travel moves going right through the part. Ooh, that's frustrating. Now it's just because I was in a hurry, though. Let's move those up above the screw. Make sure those are above the screw. That's what I get for being in a hurry and doing this. I didn't check the retract planes in Fusion to make sure that it wasn't going to hit the screw. Now, I don't have an exact replacement for that tool, but I do have the Lakeshore Carbide version of it that is coated and a little bit stubbier. And I actually like these ones better. It's also the variable, not variable helix, but variable flute, I believe, which may help me get better finishes. As long as I don't machine a screw. I forgot to home it before I touched off the tool, and the tool hit the body because it wasn't lined up with the probe. I don't think it did damage to either to anything. Well, that finally finished. The adaptive with the new tool actually went much better than the old tool. Again, I like these Lakeshore tools better than the OSG tools. Maybe they just suit my machine better. Maybe I just have better speeds and feeds for them. But they work better. The adaptive left really good finishes. My horizontal finishing path actually did not leave as good of finishes, though. I think because it was just plowing through material instead of adapting it out. So that may be something I have to change in future versions, but this is a prototype. You know what? I want my prototype to be better than this. I'm just going to rerun that horizontal. Well, it helped a little bit, not a huge amount. I'm just going to move on. We'll fix that. We'll fix that next time. Again, this is prototype, not production. I'll just hand finish it. I did want it to be better, though. So next step is doing some cleanup and actually cutting off the middle of where the screen goes with the 1/16 inch end mill. And there goes an end mill. The feeds and speeds for that slot were not right. It may have been ramping down too fast. I don't know. Obviously they weren't right though because it broke the end mill. I'm going to go back to cam and I'm going to slow the toolpath down. And as it's ramping in, I'm going to make the height of each ramp, the angle of each ramp, more gentle so that it kind of slowly feeds in more slowly. Still doesn't sound right. Well, that didn't go as smoothly as I wanted. I had to turn it down, the feed rate a bunch manually with the feed override on the computer. But theoretically, the watch is done. I'm not entirely sure that it cut all the way through, though. I'm going to run another pass and tell it to go below the material thickness. It'll cut into my fixture a little bit, but should make sure the watch is all the way loose. All right, let's see if we can get this off of here. I'm still not entirely convinced it cut all the way through, but it's hard to tell. Oh, it's free. Okay, so I'm going to take out the screw. Not with that Allen wrench, I'm not. Oh yeah, look at that. Pops right out. And there's my part. That is exciting. It's not perfect, but it's exciting. It's super light. I cannot wait to wear this. Well, I think that's all I'm going to do today. Well, you know, as soon as I turn this off, I'm going to go try to fit the watch in. But I'll do a video later on finishing this, like the actual putting a final finish onto it. I may try to anodize it, which I probably won't do on video because I've only anodized like once, and you don't want to watch me do it because I would just mislead you. But I'm super happy with this. I'm really excited to wear this for a couple days. Keep your eye out for my next video. I'm going to continue this project all the way through, hopefully to like production scale. So if that is something you are interested in watching, go ahead and hit subscribe, and you can join me on the rest of this journey.